So this is an example for the Sunspot modeling, and I'm going to use these data that I found on this website. I'm going to scroll down a little bit. Uh-oh, where'd they go? There we go. It's this one here, it's this file here, txt, which gives me then the notepad, and this is of course what I need, yearly mean total sunspot number. So I'm going to go over there it is. This one here starts in around 1700 and then goes all the way through 2020. And so the data that I'm going to use, which just arbitrarily I'm going to do 1720 through 1740. Please don't use the same data. Use another 20-year time frame anywhere on here, or use the numbers from the book. Okay, what I'm going to use from these data, and actually let me go back here. I don't need this year just yet. I will do that in a little while. But here's the data table here for Desmos. So what I actually need from these data are, of course, the years 1720 and so on. But these years, the numbers are really large, you know, for a graphing calculator like Desmos. So I'm just going to subtract 1720 from each one, which means the first one is going to be simply 0, and then the next one is going to be 1, and the next one is going to be 2, and so on. It just makes it easier for any graphing calculator to compute with those. There are 3 more columns, second, third, fourth column. I don't know what the second and the third, the third and the fourth column means, but the second column is going to be the sunspot number for each of these years, and they're just too accurate for me, so I'm not going to pay attention to the 0.7, 0.3. I'm just going to type 46, 43, 36. So I'm going to pause the video here, and when I come back, then I will have already entered these numbers. Notice that the first ones are 46, 43, 36, and the last two are 168, 121. So here we go. All right, and then halfway through entering these numbers, I noticed that, of course, Desmos is graphing them automatically, so I might as well do it while you watch me doing it. So here we go. Let's see. So there we go. So as I said, I just jotted these numbers down without the decimal, and I just rounded down. It's just too complicated to round up, and I don't need that kind of accuracy. I do want to do it accurate, but we do see that there's quite some inaccuracy already in here. You know, it's not a perfect sine curve. This looks like a strange peak here, actually. All right, so there are the data, and again, I ask you to use different kind of data, not the ones from 1720. So I'm going to turn this one on, which is going to give me a sine curve, except why is it not showing? Oh, there it is. Okay, really strange sine curve. So I'm going to try to adjust this one here when I come back. In fact, I'm going to do this first off screen, and I'm going to come back. All right, so off screen I played a little bit around with that to have a good grasp on this one here. You might notice that this sine wave here already changed. Well, that's because I changed the parameters in the meantime, because I noticed that they're going to be a little bit off. So, but they're really easy to change, by the way, and Desmos is so user-friendly. Click in here, and then you can change like the upper limit here. Right now it's 120. So I'm going to try to get this sine curve to model this one here. So obviously my amplitude has to be much larger. There we go. Around there. Okay. This is the parameter that's linked to the period. So I'm going to do this one here. I'm in the kind of negative. I don't actually like the negative too much. So there we go. Oh, somewhere around there maybe. Okay, let's see. This is going to be the phase shift. I'm going to do that in a little while, actually. I'm going to need to push this one really up. So that's the vertical translation or vertical shift, somewhere around there. That doesn't look too bad. Okay, I'm now going to try this one here. Okay, looks like the period is quite a bit off still. So, that looks better. I want to say that's basically it. I don't think I can do much more with this one here. Maybe this way. Yeah, I don't know if I can do much more with this one. So these would be my parameters for the equation, 104.66, 5.3, 104. So that's, of course, what you would have to do. And then I'm going to scroll down, and Desmos is actually going to do that for me. So it's this one here when I click this one right there. And notice the blue curve here. So this one here then gives me other parameters, like the vertical shift is 87 instead of what I had earlier. By the way, this shouldn't be here. I'll take that off. Yep. And then the period here, let's see, or the parameter that's linked to the period is 0.59. I actually was pretty close with that one. Yeah, 0.66. And again, the vertical shift is 87, and I had it 104 right there. And then let's see what else. Oh, the amplitude is 80. I have an amplitude of actually 104. And then the horizontal shift was 5.3 for me, and here it compares to 4.9, so that's actually similar. So the blue one here is the regression that Desmos does itself, and the dashed black one, that's the one that I tried to do by shifting these values. And you're supposed to do 2 and then submit that, and yes, pay attention to the other instructions that are listed for the project in the book and in my Word document. After I was done, I noticed that I want to point out a couple more things. One of them is that this parameter here, right there, of course, is linked to the period. So 2 pi divided by 0.66, top of my head, that gives me about 9.5. So 9.5 years, which compares to the actual one of about 11 years. So given that these are only 20 years worth of data, hey, that's not bad. And you should also come up with things like that. Okay, the other thing I want to point out is actually kind of how Desmos works. This is really straightforward. This is all you really have to type straight along, and these are parameters, the a, j, d, c, while the x and the y are the variables that are being plotted on this xy graph. This one here is a little bit trickier, so you would have to say, okay, a equals this one here, respectively this shifter here, or whatever that is called, and then you have to put the step in. You would have to see how you do that. But again, you don't actually have to do it because I already did it for you. This one here is really easy. All you have to do is type in table, and you come up with this one here. And this one here isn't too bad either. This is the regression, so where it takes the data that are plotted here and puts an equation around it. Now notice this looks almost the same as the top equation here, but there are a couple of crucial differences. One of them is that instead of calling these variables x and y, they're called x1 and y1, which goes with the table here. By default, you get x1 and y1 here. You can change those to x2, y2, or what have you, and then you will have this. The other crucial change is that up there you found an equation. Here you found a proportionality. So you need this one here to say, okay, this one needs to be proportional, but it doesn't have to be exact because it is trying to model these data that you have here. All right, and then it gives you everything back here. The r squared, by the way, here, that's an indication on how good the fit is. 0.92, the closer it is to 1, the better, so 0.92 isn't too bad for these kind of data. All right, that's, again, what I wanted to point out after I already was done with the graphing example.